Okay, so this is the first problem. This is once again is equilibrium constant, and this one shows here there are two reactions shown up here. One is, I guess, methane is converted into the ethane, and second one is methane is react with the water to generate the methanol. But the reaction equilibrium constant that I want to know is what it will be happen when methanol and hydrogen reacts. They produce this. So I look it up, and methanol appears on the right hand side, but this one appears on the left hand side. So I want to flip this equation. That's the first thing that I want to do, because I want to use these two equations up there. So what I do is, okay, then I will write this equation upside down. CH3OH. All I did is just to flip the equation upside down. CH4H2O. And then this new Kc value should be inverse of the number shown up above here. So that's the one. Okay. So because it's a Kc is always a ratio between product divided by reactant. If your product became reactant by flipping the reaction, this one is just an upside down. So that's the number. And then I see that, oh, not only that, I see the 2 here. So I'm going to multiply by 2. Okay. So if you multiply by 2 means the power. So you need to do things to the power of the 2. Okay. So that's what I have. And this number, if you put in the calculator, you will get 1.3 10 to the 41. That's the one you. Okay, so then I am going to rewrite this equation, just copying down the equation one more time. 2 methanol, 2 hydrogen, 2 methane, 2 water. Okay, so and then this one is Kc, concentration base equilibrium constant, 1.3 10 to the 41. Okay, I got it. What about the one in the top? And I see ethanes here. Where do I see ethanes here? Okay, so I don't need to flip this one. So I'm just going to copy down as it is. So it will be ethane C2H6 and the hydrogen. The other side is 2CH4. And let's see what happens here. And so because I just simply copy down Kc, just the same number, 9.5 10 to the minus 15. And for the convenience, I'm going to write this one as a Kc for reaction 1, Kc for reaction 2. So it's just a numbering way of these two. And then I'm going to add them up. And this one conveniently gone. This one, this is gone. And looks like I have a reaction of gone. Right? So all I did is just simply adding these two reactions. So for this reaction, therefore, Kc is a Kc1 multiplied by Kc2. This is the same reason that when you just double it, you're adding these two equations together. So this Kc constant multiplied by itself became the square, same thing as here. So by adding these two reactions, this your equilibrium constant is the product of those two. Okay. So we can just. So it just this one is an easy problem. Just want to give you the concept about when you change the reactant into the product. If you switch that, there will be an inverse. If you add them together, reaction constant will be multiplied. So you can get to understand the meaning of this.